This is an explanation and solution to questions 28 to 36. Prepare yourself a calculator and ruler before you start. In the last video, I have showed you how to finish part A, and I have also given to you some hints to finish part B, C, and D. Some of you have already finished part B as well by drawing two light rays from the image of Mary to Mother. Some of you even draw the incident rays from Sam and Mary towards the mirror. So what about part C and part D? I would like to start with part D, which is easier. In order to calculate the minimum length of the mirror for Mother to see Mary in the mirror, you should draw these two triangles. The blue triangle and the orange triangle are actually similar, and you can see they have different lengths. One has a length of 6 meters, and the other has a length of 3 meters. In this way, you may compare the height of Mary with the length of the mirror, so that you have the following expression. That is, 3 over D equals 6 over H, which is height of Mary, so that you may find the minimum length of the mirror, which is D here. What about part C then? For part C, you have to draw another pair of triangles, the purple and the green one. It looks like that. Similarly, you have to compare their lengths. And in that case, you can see for the green one, 3 meters. For the purple one, 4.5 meters. In that case, you may also have a similar equation, which is 3 over C equals 4.5 over H, height of Sam. In this case, you may also calculate the minimum length C easily from the equation. So it is not always the case that the minimum length of mirror is half of the height of the person in the mirror. It depends on how far away the observer is from the mirror and how far away the image is from the mirror. For Mary's case, because Mary and Mother are both 3 meters from the mirror, so the minimum length of the mirror is just half the height of Mary. But for the Sam's case, because Sam is 1.5 meters from the mirror, while Mother is 3 meters from the mirror, so the ratio will be a bit different. It is not half of Sam's height anymore. And now let's move on to reflection. Question 29. For that question, there are 3 different cases, A, B, and C, but they are quite similar. In all these cases, the light ray travels from air into another medium of different refractive index. For the first case, you have to find the refractive index of the second medium. In the second case, you have to find the refracted angle x. For the third case, you have to find the incident angle, the angle in air. For all these cases, you apply the same equation, which is eta, refractive index, equals the sine of the angle in air over the sine of the angle in the second medium. You must be familiar with how to operate your calculator to find the sine value of an angle, as well as to find the odd sine angle of a value. Question 30 and question 29 look pretty alike, but in fact, they are not the same. You can see from part A of question 30, the angle of incidence is smaller than the angle of refraction, which is not the case in question 29. In fact, the light ray here travels from the medium X to air. So the ray diagram looks like this. The angle 40 is found inside the medium X, and the angle 60 is found in air. So the refractive index is given by sine 60 degrees over sine 40 degrees. Similarly for part B and part C. It's interesting to see that you have no solution for the angle X when the angle of incidence is 40 and the refractive index is 1.8. There will be an explanation on page 49 of your book in the next chapter. So just let it be for the time being. This is question 31. Light rays travels from air to glass and to air again. You can see the angle in air is 60 degrees, and so we may apply the Snell's law directly, that the refractive index of glass equals sine 60 over sine x, where x is the angle in glass. You can easily find x by solving the equation. By the way, in this situation, the light ray will finally go out from glass to air again after passing through the rectangular glass block. And you can see that this light ray coming out from the glass block is actually parallel to the incident light ray. That is to say, for the second refraction here, the incident angle is this 34 degrees, and the refracted angle in air will be 60 degrees again. For question 32, there are three different layers: water, air, and then glass. So you have to apply the Snell's law twice. First of all, from water to air, the equation will give 1.33 equals sine x over sine 38 degrees. This x is the angle in air, and 38 degrees is the angle in water. After you have found x, which will be about 55 degrees, you may substitute it in the Snell's law again in the second refraction, so that 1.55 equals sine 54.96 degrees over sine y, where y is the angle in glass. And eventually you will find y to be something like 32 degrees. Question 33. It seems to be a difficult problem for most of you because you are not familiar to give explanation. Here we go. It's actually from the calculation of question 32 that we have found that the thickness of the air layer does not affect the angle in glass. From the last slide you can see we don't have to calculate using the thickness of air. So the thickness of air is not that important. On the other hand, if you look at the equations that you have used in question 32, then you may have the following observation. You may see that sine angle in water multiplied with the refractive index of water will equal to sine the angle in air multiplied with the refractive index of air, and that will also equal to sine of the angle in glass multiplied with the refractive index of glass. You may apply that equation in all other cases, such as question 34, 35, and even 36. For question 34, we have water, we have glass, but we don't have air, so we may apply the equation that we have just found. We find the product of the sine of the angle and the refractive index of each layer. For water, we have sine 42 degrees multiplied with refractive index of water, which is 1.33. That will be equal to the sine of the angle in glass multiplied with the refractive index of glass, 1.55. In this way, you can find sine x, and then by using your calculator, you may find the angle x easily. Similarly, for question 35, you may have sine 30 degrees multiplied with the refractive index of glass, which is 1.55, equals sine y multiplied with the refractive index of water, which is 1.33. Lastly, we move on to question 36. It's not that a difficult question now because you have that very useful equation. So we may have sine 21 degrees multiplied with the refractive index of diamond, which is 2.42. And the value is 0.86725. You may use this value for all other layers such as glass, water, and air. So we may have sine x multiplied with 1.55 equals 0.86725. Similarly, for sine y multiplied with 1.33 and sine z multiplied with 1.003.